Okay, so let's consider the integral from 0 to 1 of 1 over the square root of x. So once again, we have an asymptote at 0. So we write it as limit as b approaches 0 from the right, above, of the integral from b to 1 of x to the minus 1/2 dx. So we apply our integration techniques. Limit as b approaches 0 from the right. So here we would add 1 to it, which would make it x to the 1/2. Divided by 1/2 would be times 2. So that's actually going to be 2 square root of x. And we're evaluating between b and 1. So we go through limit as b approaches 0 from the right of 2 square root of 1, which is 2, minus 2 square roots of b. And this time we can just let b become 0, because 2 squared of b, 2 squared of 0 is just 0. We have 2 minus 0, which is 2. So it turns out the 1 over the square root of x function, its graph is actually closing in with the asymptote quick enough that we actually do have a finite limit. So what you're seeing here is if we go into our Desmos graph here, let me go back and kind of zoom out here a little bit. And if I throw in y equals 1 over x squared and y equals 1 over square root of x, I want you to notice the big difference here as we get close to 0. Notice all the space between the 1 over x squared graph and the 0. That's why we have that infinite, end up having an infinite amount. It's just not getting close to the 0. It's not hugging the asymptote quick enough. Whereas the 1 over square root of x is definitely hugging that thing really quick. You can definitely see that. And of course we see the contrasting result the other way, right? 1 over x squared is hugging the x-axis really quickly. That's why its integral actually turns out to be a finite amount from 1 to infinity. Whereas the 1 over square root of x, which we tried from 1 to infinity as well, or something similar to that, did not. Actually, I think we did 9 to infinity on that one, but same idea. It's just not hugging it quick enough. And so it kind of comes down to that idea of when is it hugging it quick enough? When is it getting close to either the horizontal or vertical asymptote quick enough? That's really what it comes down to. Let's look at another one. Let's look at another one here. The integral for 1 over x, turned out it didn't work, right? When we went to infinity. Well, what if we go towards the vertical asymptote? Well, this would be limit as b approaches 0 from above, the integral from b to 1 of 1 over x dx. Okay. That would be the limit as b approaches 0 from above of the ln of x, evaluated between b and 1. And that would be the limit as b approaches infinity of ln of 1, which is 0, minus ln of b. And unfortunately, as b goes to not infinity, sorry, there it should be, b approaches 0 from the positive direction, the ln graph actually approaches negative infinity. So you get negative of negative infinity is positive infinity. This thing diverges. Next, again, as you approach 0 from the positive direction on the ln graph, just throw it in here real quick for you to see. right? You have that asymptote there. You have that asymptote. We have that asymptote. It is going down towards, as you can see here, it's going down towards minus infinity as we approach zero from above. And so therefore, this integral for 1 over x is also going to diverge. So 1 over x actually doesn't work either way, right? When you throw him in there with right, it doesn't get close enough to the x-axis on the horizontal asymptote behavior for it to be finite, and it doesn't close in with the y-axis fast enough when you're approaching your vertical asymptote for us to have an actual limit. In fact, he's kind of the cutoff, If you're closing to the y-axis faster than the 1 over x, then you're going to converge. If you're closing to the x-axis faster than the 1 over x, then your integral to infinity there is going to converge. 1 over x is kind of that middle guy, the guy in the middle there, where he's at the extreme, just missing out. And so that's where you get his product. Okay, so the result again of our two integrals here, the 1 over square root of x does converge to a finite amount. The 1 over x does not. And again, you can see the difference graphically here between the 1 over square root of x and the 1 over x. The 1 over square root of x is getting there much, much quicker than the 1 over x. And that's the problem. That's the problem there.